evaluate the limit. So here we have limit of x minus tangent x over x cube as x goes to 0. So we got two terms on the top and x cube on the bottom. If we directly plug in 0 for x, so this is 0 minus tangent of 0. Tangent of 0 is 0. We can check in our calculator. So 0 minus 0, that's 0 over 0 cubed. So basically we got 0 over 0 here and indeterminate form. Okay. The good news, to evaluate this limit, when we have 0 over 0, we factor the top, factor the bottom, and cross out the common factors. But since we have tangent, we can't factor anything out here. I mean, this x is not a product with tangent. It's a tangent of x, okay? Do not try to factor x and cancel. And if you remember correctly, when we have 0 over 0 or infinity over infinity, then we can use L'Hopital's rule. What is that? L'Hopital's rule means when to evaluate this limit will be same as the following limit. I am writing L'Hopital's rule. I am applying L'Hopital's rule here. So this limit is same as this limit. Limit x tends to 0 of, we find the derivative of top on the top and derivative of bottom on the bottom. So bottom is just 3x squared. Top, derivative of x is 1 minus tangent x. Derivative of tangent is secant squared. Okay. Now let's plug in x equals 0. As long as we get 0 over 0, we can apply L'Hopital's rule. Okay. X 1 minus secant 0. What is the value of secant 0? When this is square means secant x quantity square. And secant square x is shorthand notation for this one. Secant x, secant is 1 over cosine. Secant is reciprocal of cosine square, or we can write 1 over cosine square. Okay, cosine of 0, that's 1. Check unit circle or your calculator. Cosine of 0 is 1. 1 over 1 is 1 squared, so this is 1. So secant square 0 is 1 in fact. Over, that's the 0, 3 times 0 squared. So 0 over 0. So again we get 0 over 0 after we simplify this. Okay. That means we can apply L'Hopital's rule one more time, because we can't factor anything on the top and bottom and cancel. There is nothing to factor. So L'Hopital's again, limit x going to 0 of, on the bottom derivative is 6x, that's the easy part. Okay. On the top derivative of 1 is 0, no need to write, minus secant square x. Okay, we know that secant square x is in fact secant x is squared. Okay, something is squared. So when we find its derivative, it's the power rule combined with the chain rule. Okay, secant square x, that is secant x quantity squared. It's like something is squared. When we find its derivative, if we think like x is squared, that would be 2x, right? 2 secant x, but this is not only x, this is secant x. So from the chain rule, we find the derivative of inside function here. And derivative of secant is secant tangent. Okay, so derivative of secant square x is in fact, because secant x is squared, that's 2 secant tangent. And is a negative sign, 0. I'm just dropping 0. This one is 2 secant tangent. So 2 secant square x times tangent x. We were supposed to write parentheses around x, but I'm dropping that. Okay, 2 secant square times tangent. With a minus sign, we can pull to the front. 2 6. In fact, we can cancel. 2 goes once. 2 goes 3 times. If we plug in 0, secant squared 0, that's 1. We know that, that's 1. Here, we figured out earlier, secant 0 is 1, tangent 0 is 0, 0 over 0. So we have now we can still use L'Hopital's rule, but there's a tangent x over x. Okay, if you remember correctly, there was one limit of x going to 0 of sine x over x. Okay, this limit is 1, and we also saw that limit of x going to 0 tangent x over x is also 1. I mean, we can check this using L'Hopital's rule, by the way. I saw tangent x over x, so I'm going to write this in this way. This negative 1 on the top 3, negative 1/3, we can pull outside if we like. 0. Here is now secant square x, then tangent x over x. So I'm going to write down tangent x over x in one place and secant square x. Parentheses or without parentheses still fine. Now this limit of product is product of limits. We can apply limit here and here. But this alone tangent x over x, when x goes to 0, this goes to 1. And secant squared 0, that's 1. Okay, secant is 1 over cosine, and cosine 0 is 1. So this is 1. Oh, this is 1. This also goes to 1. I mean, this is exactly 1. I mean, this limit is going to 1, but this value is 1. Okay, let me put that way maybe. And this will be just 1. Then negative 1/3 times 1 times 1. So the final answer is negative 1/3.